Okay, so in this video, I'm going to be going over the oxidation practice homework. So I'm going to try to do as many as I can to kind of hopefully help you out on some of these. And you'll notice that some of these are going to kind of be the same thing we've been doing, and some of it's from the new notes. Okay, so let's kind of start off is I'm going to do this first one, CCl4. Okay, so normally we would look up chlorine on the periodic table has a charge of -1. Oops, let me turn my pen on real quick. Okay, I have a charge of -1, and then carbon would have a charge of +4 in this instance. Okay, you can do the reverse crisscross, so if I only have one carbon, I would take that up to the chlorine. And if I had 4 chlorines, I would take that up to the carbon. Okay, so I can still write this out the same way we did kind of in the notes, is if I had carbon, and then I only had 1 carbon, and then I had 4 chlorines. Okay, I'm going to draw my sum line, and then I would look let me clear up some of this a little bit. I would see, do I have a charge right here at the top right-hand corner? I do not, so that means you're going to set it equal to 0. Okay, so since chlorine has a charge of -1 on the periodic table, and I have 4 of them, that means my total charge for chlorine would be a -4. Okay, and if you wanted to make sure what carbon was, okay, you would know what -4 gives me 0. That would be a +4. And since I only have 1 carbon, that means each carbon would have a charge of +4. So my answer would be C equals +4. Okay, and then chlorine would be -1. So that would be my answer for number 1. Now, you have barium, so BaSO4. Okay, so remember our first step was to kind of split it apart. So Ba, only have 1 of them. Sulfur, I have 1 of those. And then I have 4 oxygens. Okay, and again, on this, I'm writing kind of big, so if you need to write smaller on your homework, that's fine, or just kind of write all over the page, that's up to you. Okay, I'm going to draw my sum line, and I'm going to look, do I have a charge right here? I'm going to say nope, okay, because there's nothing there, so we're going to set it all equal to 0. So remember, our first step would be look at oxygen. So oxygen is your -2, has a charge of -2, and I have 4 of them, so that equals out to a total of -8, or -8. Then your next step would be to start with would go to your metal, and that would be barium. And barium has a charge of +2. Okay, and since there's only 1 of them, 1 times +2 would be +2. Now I need to figure out what is the charge of sulfur here, okay, by finding out what is the total charge of sulfur here. Okay, and I know my total equals out to 0, so I need to figure out 2 plus what? -8 gives me 0. Okay, so hopefully you can kind of figure that out, it would end up being 2 plus 6 minus 8 would equal out to 0. Now what you would do is you would take that +6 and divide it your total for sulfur and divide it by however many sulfurs you have, which is only 1. So that means the charge of that sulfur would be +6. So I can erase this part, and I can put a +6 right here. Okay, so my answer for this would be Ba equals +2. And then sulfur equals +6, and then oxygen equals -2. So that would be my answer right there. Okay, now when you get to something like number 3, okay, you can see that this is not a polyatomic, so you could honestly just do the reverse crisscross if it works. So I would take the 2 up here to the oxygen, and that would make it a -2, okay, which would be correct, okay, if you look on the periodic table, and I would take the 3 up here to the iron. So my answer for this one would be Fe equals +3, and oxygen equals -2. So again, some of these are simple. They're just kind of a reverse crisscross of the stuff we've been doing. It really just comes out to end up being the polyatomics when we start getting into a little bit of confusion. Okay, so I'm going to take a look at number 5 right here. So the first thing I'm going to do is I'm going to spread it out. Okay, and I'm going to use a different color ink, okay, because I don't want it to kind of blend in. So I'm going to spread them out. So I have K, I have potassium, I only have 1 of them. I have 1 manganese, and I have 4 oxygens. I'm going to look do I see a charge up here in the top right? I do not, so that means when I sum these up, they're going to equal out to 0. So I'm going to start off with oxygen. Oxygen always has a charge of -2, so 4 times -2 gives me a -8. Okay, my next step is to go on to the metal. Okay, next would be potassium. So manganese is technically a metal, okay, but you always want to save whatever's attached to oxygen for last. Okay, so I'm going to look at potassium, and potassium's in group 1, so that has a charge of +1. and there's only one of them, so 1 times plus 1 would give me plus 1. Now I need to figure out is what is going to be the total charge for manganese right here. Okay, so I need to know 1 plus what minus 8 gives me 0. Well, this would have to be a positive 7 because I would know 1 plus 7 equals 8 minus 8 equals 0. So you're going to take that positive 7 and divide it by however many manganeses you have, which is only 1. So 7 divided by 1 gives me 7. So that means the charge of manganese would be plus 7. So my answer would be potassium has a charge of plus 1, manganese has a charge of plus 7, and then oxygen has a charge of minus 2. Okay, so let's move on to the next. So I think I did SO4 minus 2 in my notes. Okay, but I can do that again just to make sure everybody's on the same page. Okay, so I'm going to take a look. I'm going to spread this out. I only have 1 sulfur, and I have 4 oxygens. Okay, and then if you look, I actually have a charge here of minus 2. Okay, so that means I'm going to set it equal to minus 2. So we always start with your oxygen. So oxygen always has a charge of minus 2. So 4 times the minus 2 would be a negative 8. Now I need to figure out what minus 8 gives me a negative 2. Well, that should be a positive 6. Okay, so I would take that positive 6 and divide it by however many sulfurs I have. Okay, and that would give me a positive 6 for sulfur. So this positive 6 would be right here. So my answer would be S equals positive 6, and then O equals minus 2. Okay, now when you get to some of these examples like right here, like I2, is if you don't see anything there and it's only one element, okay, that means it's 0. So your answer for iodine would just simply be 0. That's it. Okay, number 10, if you see this positive 8 and there's only one element there, that means the oxidation for chromium is going to be a plus 8. Okay, so let's see if we can find something a little more difficult. Okay, so let's jump onto the back page where you see Al2SO3 Okay, so let's do this one right here, number 3. So I'm going to spread them out. So I have 2 aluminums, and remember, if you have a parentheses, you have to cross multiply. Okay, so I'm going to take this 3 and multiply it by that 1s. So that means I have 3 sulfurs, and take that 3 and multiply it by your 3 oxygens, and that means I have 9 oxygens. Okay, so make sure you're careful with those parentheses. That 3 does not carry over to that aluminum because it's not in that parentheses. Now I'm going to look, do I have a charge up here in the right-hand corner? Once I clear this up, do you see a charge up in the right-hand corner right here? That'd be no. So that means my total is going to equal out to 0. Okay, so my first step is to do the oxygen. So oxygen's a minus 2. So 9 times a minus 2 would give me minus 18. Okay, my next step is to move on to a metal if I have one. Okay, so something that's not attached directly to that oxygen, which would be aluminum. And if you look up aluminum on the periodic table, each one has a charge of plus 3. So 2 times positive 3 would give me plus 6. Now I need to figure out is 6 plus what? Minus 18 gives me 0. Well, 6 plus 12 minus 18 would give me 0. So now what I'm going to do is I'm going to take that 12 and divide it by however many sulfurs I have, and I have 3 of them, so 12 divided by 3. That means each one has a charge of plus 4. So my answer would be aluminum has a charge of plus 3, sulfur has a charge of plus 4, and oxygen has a charge of minus 2. So that would be your answer right there. All right, so we'll do one more. Okay, we'll go ahead and just do the one right below it because that looks like a complicated one. Okay, so I'm going to spread it apart. I have 3 zincs. I'm going to cross multiply. I have 2 arsenics. And I'm going to cross multiply the oxygens. I have 8 oxygens. Do I have a charge? No, I do not. So that means I'm going to set this all equal to 0. So if there was a charge there, you would just simply you would set your whole thing equal to whatever that charge would be. And since there's not one, that's where we're going to set equal to 0. So I'm going to start with oxygen. Oxygen has a charge of minus 2. So 8 times minus 2 would give me minus 16. Okay, then I'm going to come over here to my zinc. So zinc, if you look up on the charge of the periodic table, has a charge of plus 2. Remember, that is one of those transition metals that is always plus 2, and you don't need a Roman numeral. Okay, so 3 times plus 2 would give me positive 6. So I need to figure out 6 plus what? Minus 16 gives me 0. Okay, if you figure that out, it would be 6 plus 10 minus 16 equals 0. Now I'm going to take that 10, that total 10, and divide it by how many arsenics I have, and I have 2 of them. So that means each one has a charge of plus 5. So my answer would be zinc has a charge of plus 2, arsenic has a charge of plus 5, and oxygen has a charge of minus 2. Okay, so hopefully that kind of helped explain how to find the oxidation or charges in the polyatomic. Okay, so again, it's not that bad, so feel free to go back to my notes or watch this video again or some of these examples, or ask any questions if you need any help.